Okay, let's review scatter plots and two-way tables. First of all, this is a scatter plot that is telling about the fuel gauge as a driver drives and how much gas that they have in their tank. So you can see as the driver drives over so many hours, the gallons in the gas tank go down. So we have a negative correlation. And we can see there is a correlation because we can see the pattern of our data points decreasing as the X values increase. So as hours of driving increase, our output gallons of gas decrease. So we are asked to write a linear model of our line of best fit, and we're going to use 0,38 and 8,6. So 0,38 is about right here. So we're going to use this data point, and then 8,6 is about right here. So typically we take an ordered pair from the one end of the line of best fit or near the line of best fit, and then another data point at the other end. So we are going to write our line of best fit in slope-intercept form. So the first thing is we're going to use our slope formula to find the constant rate of change of the fuel gauge. So our slope is going to be y2, 6 minus y1, 38 over 8 minus 0. 6 minus 38, that gives us a negative 32 over 8. So our slope is negative 4. And we knew the slope was going to be negative because we have a negative correlation. Now, we need to find the Y-intercept, but the ordered pair that was given, this ordered pair 0,38 is the Y-intercept. This 38 is the B value. So we only have to just put it together. Y equals negative 4x plus 38. And we can use this linear model to answer various questions, such as how many gallons left in the tank at maybe 4 hours of driving. So remember to always define what X and Y represent. And you can always use your labels if you're given a graph. So X is the hours of driving and Y is the total amount of fuel in the gas tank. So if we did want to know how much gas was in the gas tank in 4 hours, we would plug in 4 for X and we get negative 16 plus 38. And then we combine those, and that's going to give us 22. So we would have 22 gallons of gas. So the linear model is to help us use to make predictions and answer various questions. Okay, let's take a look at one more. In this graph, it is showing that it's basketball practice is our title. So you can see that this is as the hours of practice goes up, the points per game also goes up. So we do have a correlation. The scatter plot is showing a positive correlation. And again, we're going to find the linear model of the line of best fit. And so they are giving us 2, 0 and 12, 20. So let's go ahead and find the slope. So we have y2 minus y1 over x2 minus x1. This gives us 20 over 10, and that gives us 2, a slope of 2. So we have y equals 2x plus b. Now we don't have the y-intercept. This ordered pair is the x-intercept. It is not the y-intercept. So to find the b value, we can use either of these points or any of these points in our data to put in for x and y. I'm just going to pick this point here, and 2 is your x and 0 is your y. So I'm going to plug 0 for y, 2 for my x, and now we're going to calculate and find the b value. So we're going to isolate b. We're going to subtract 4 from both sides, and the B value is -4. So now we can write our linear model y equals slope of 2x, slope is 2 times x minus 4. This time, again, x is hours of practice, and our y is total points per game. So let's just see if we want to make a prediction if we practice for 14 hours. So let's put in 14 for x and see what is the prediction that we would make in a game. So we would make 24 points. Now let's go over two-way tables. We're going to first take a look at a two-way frequency table, which just houses all of the data of a survey that we have taken. In this survey, we are looking at 7th and 8th graders and how many hours of sleep that they got. And remember, you're definitely going to need a calculator for this lesson. So we have surveyed 360 people, and now we need to fill in the missing numbers. So we can just use what we have, and here we can subtract and get 187th graders. Then we can find this value a couple of ways. I can just subtract 40 from the 160 or 60 from the 180. And then we have 40 from 180. And then we can add this column together and get 200. Now we're going to take a look at a whole table relative frequency. So remember, the word relative just means percent. And the way that you calculate percent is the part divided by the total times 100. Now remember, in a two-way table, we have several totals. We have the total that was surveyed, and then we have the total of the rows and the total of the columns. So the whole table relative frequency is going to be using the total surveyed to find our percentages. So we are going to be dividing every cell number by 360, and then of course multiplying by 100. So we're going to divide these and then multiply by 100. I'm not going to write that on the board, so I'm just going to be calculating each of these. And I'm going to round to the 10th. And of course, 180 out of 360 is half, so that's going to be 50%. Okay, now that we have all of our percentages, let me just give you some examples of the questions that would be asked when you use the whole table relative frequency. So a question that says, of those that were surveyed, what percent are in 7th grade? And we would say 50%. We could be asked, of those that were surveyed, what percent are 8th graders that sleep 7 to 10 hours? This would be 11.1%. You could be asked, of those that were surveyed, what percent are 7th graders that sleep 3 to 6 hours? 16.7%. So when the question is asking of those that were surveyed, you're going to use the whole table relative frequency, which was each cell being divided by the total surveyed. So it's about how the question is asked. Now we're going to do conditional meaning we're dividing by the row or the column. So the word conditional means we're going to focus either on the total of the columns or the total of the row. And this one says by column. So we are going to be dividing by the column total. So this column has a total of 160, and this column has a total of 200. So again, we're going to divide by the column totals and then multiply by 100. So let's calculate these. So now that we have these values, these percentages, again, remember relative just means percent. Questions where you would use these percentages would be questions such as, of those that sleep 7 to 10 hours, what percent are 7th grade? And you would see 75%. Or of those that sleep 3 to 6 hours, what percent are 8th graders? 70%. Excuse me. So you can see this conditional relative frequency table by column really narrows down and shows that I could predict students who get more sleep are more likely to be 7th graders than 8th graders, 75% to 25, and those that get little sleep, 3 to 6 hours, are more likely to be 8th graders. So there is an association of hours of sleep and grade level. So that's why we do conditional relative frequencies, to see a clear picture if there is an association between the two variables. Okay, now we're going to do conditional relative frequency by row. So we're going to be looking at the row total. So we're going to be dividing by the totals of each row, and they happen to be the same total of 180. So we surveyed equal amounts of 7th graders and 8th graders. So remember, we are dividing part divided by the total and then times 100. Okay, so let's go over some questions that you would be asked when you would use this table of percentages. So if a question was, of those in 7th grade, what percent sleep 7 to 10 hours? So we're just focusing on the 7th graders. So of those in 7th grade, 66.7 sleep 7 to 10 hours. Or if I was asked, of those in 8th grade, what percent sleep 3 to 6 hours? And you can see that this is 77.8%. So again, you have to look at how the question is being asked to know which table to use. So we can see clearly that the 7th graders here, there are a larger percent that sleep 7 to 10 than 3 to 6. And then if you're in 8th grade, you're more likely to get less sleep. So we can again see there is an association of grade level and hours of sleep. And I hope this helps.